In this recording, we're going to take on some kind of classic word problems called consecutive integer problems. First off, we need to know what this word consecutive means. Okay, so I think you may have come across that word. All right, so 4, 5, and 6 are consecutive integers, numbers that come in order. Integers being whole numbers and their opposites. So they could be negative, I suppose. Okay. So numerically, what does it look like to have 3 consecutive integers? Well, the example I gave was 4, 5, and 6. How would that look like on a graph? Well, let's just place 4, 5, and 6 here on our number line. You're just jumping one number at a time, okay? They're supposed to be like little arrows. Okay, well, we'll say I call the first number x, right? Because in our last video we talked about how we're going to use x or n or some other letter to represent our unknown. Well, in this case there's several unknowns. If I've got 3 consecutive integers that I don't know are 4, 5, and 6, well, the first one I could call x. The second one is 1 bigger, so I could call that one x plus 1. So it's just sort of implied that the second one is x plus 1. And the third one is 2 bigger than the first, so I'd call it x plus 2. Okay. Another type of question we may ask is about consecutive even integers or consecutive odd integers. Well, think of your favorite 3 consecutive integers that are even. I might go with 4, 6, and 8. You may use others. Try to pick numbers that are on here, though, on our number line. It'll make it easier. So if I'm jumping from 4 to 6, and then from 6 to 8, we're jumping by 2s. So I can't just say the second number is 1 bigger. I have to say it's x plus 2. And the third number obviously would be 4 bigger because I jumped 2 number jumps. So x plus 4. Finally, consecutive odd integers. Pick your favorite 3 consecutive odd integers that fit on this number line. I could, of course, have negatives, but let's just keep it simple and keep it to the positives. I'm going to go with 3, 5, and 7. You may have chosen others. So if I jump from 3 to 5, and then from 5 to 7, I'm still jumping by 2s, right? So not much difference here. It's just that the starting number needs to be odd. Right? So our first number is going to be whatever it is. The second number is 2 more than that because I have to jump to the next odd. So x plus 2. And of course the last one is an x plus 4. Okay? You might want to pause here and just take a second to take that all in because it's a bit. When you're ready, let's move down to the first question and we'll try to solve these together. Okay, so the first question says find 3 consecutive integers. So it doesn't say anything about odd or even. So we know that they're going up by 1 each time, just like in this purple. And we have some details, right? Some specific clues. Twice, so that means like 2 times, right? 2 times. The smallest, remember the smallest would be like whatever the x is 12 more than the largest. Oh, okay. Well, the largest, let's go back up to my list of facts here. The largest would have to be x plus 2, right? So it would be like I'm just talking about x plus 2 here. And 12 more than would have to be a 12 plus, right? Okay, so I think we have enough to work with. Of course, is an equal sign. So let's work with this. So we first have to lay out our variables. So let's do that over on the side here. I have to concentrate a little bit here when I'm talking about the next consecutive integer. Do I skip by 2s or do I skip by 1s? Remember, consecutive, we didn't say anything about odd or even, so we're just skipping by 1. So the next biggest integer is 1 bigger, and then all right. Good, so we've got our 3 integers laid out for ourselves, and it says twice the smallest. So the smallest was just x, so 2x. is equal sign 12 more than the largest. So we'll start with our largest, put it in parentheses, although the parentheses won't have any effect because there's no coefficient, plus 12. Okay, so solve that out, play the recording when you're ready. Okay, so hopefully you took the time to solve this. 2x equals, the parentheses have no effect because of the lack of coefficient here. So just add like terms. Solve for x by subtracting x. So we think the first number is 14. Therefore, the next two consecutive integers, 15, 16. So we think those are the numbers. And we'll want to check this. So let's see if it has our characteristics. We have 3 consecutive integers. Great. Is the case that twice the smallest, so that would be what, 28 here? Just kind of write some scrap work. Is 12 more than the largest? Well, our largest is 16. 16 plus 12. Yep, that's 28. So it checks out. All right, last example we're going to look at raises the bar just a little bit. I'll have you read through example 2 and see why this one is more challenging. Okay, so hopefully you picked up on the fact that it is consecutive odd integers. And we want to know their sum. So we've got to lay out our let statements. Let's have you do this on your own and then play the recording when you're ready. Okay, so hopefully you paused, laid out your let statements. Let's see how well you did. They're going to look a lot like what we have up here. Okay, concentrate. If the first number is an odd integer, the next odd integer has to be 2 bigger. So we're skipping by 2, so x plus 2 here, unlike what we had before. Once we have our variables defined, it's going to be pretty easy because I just need to find their sum. See if you can write out the equation that represents the sum of those 3 numbers. Then play the recording. Okay, so I'm really hoping you paused and worked this out. X plus 2 plus x plus 4 equals 339. Okay, if there were any coefficients or negative signs, I would need to distribute them, but because there's not, I can essentially ignore my parentheses. Okay, so x plus x. Well, actually, you do this. You solve this out, and then play the recording. Okay, so x plus x, 3x plus 6. You might feel like you need a calculator here, guys, but it's actually not that hard. If you're dividing all of those by 3, 300 is 1, 30 is 1, 3 is 1, so we got 1, 1, 1. Okay, so 1, 1, 1 would be our first number, and we're going up by odds. Those should be our numbers. You could use mental math or a calculator to add them up to see if in fact they do add up to 339, and we can certainly tell that they are odd and consecutive. Thanks for watching.